First speaker, Ivan Angelov, did I pronounce that correctly?
Yeah, you did.
Who's going to be talking about continuous delivery from 0 to infinity.
Yeah.
Take it away.
Cool. Thanks for coming, guys. Thanks. It's actually going to be my first presentation. So I was contacted by a small startup that needed some help because they had an unfinished product and they didn't really know how to deploy it or even where to run it. I mean, both the operating system, the cloud provider, they were also geo-distributed, so they were working 24/7. The product was microservice-like. It consisted of 6 different microservices tied together by Akka clustering. All of them were using Akka. They had no real dev workflow, so the code base was mostly developed by a single developer. So they didn't have anything like continuous integration, delivery, whatever. So that is the problem. What they wanted to have is a scalable, performant, secure, cloud-agnostic, easy to debug and operate, and one-click performance testing. So, scalable. This startup had a product which was an IoT platform. As you might imagine, there are a lot of devices that need to push and pull data from it. Performant, they needed it to perform very well, very fast, without much overhead. Of course, it needed to be secure, which is kind of a problem with Docker, but it's becoming less of a problem nowadays. They needed it to be cloud agnostic because the clients might have requested to have it installed in their on-premises data center or in a different cloud provider. Of course, distributed systems are notoriously hard to debug and operate, so this was a prerequisite since there weren't many people that were able to operate such system. And one thing that they wanted explicitly was one-click performance testing. So they wanted to be able to compare how the software performs with its different revisions. So for example, we were testing different serialization mechanisms, and this proved to be really, really nice to have. They have heard about Docker, and obviously they wanted to have it, but didn't know how to deploy it. So what we decided was to deliver the software continuously, because since we were starting from 0, it just sounded like the best solution in order to be able to ship the software very fast. We also decided to use Akka clustering. We could have deployed it in a typical microservice manner, and the service could have communicated by HTTP, but since we wanted to have as little overhead as possible, and Akka sharding was really, really nice to have, we decided to go that way. We also decided to use Apache Mesos, since that allowed it to be very elastic and scale up and down with the demand. And the framework of choice was Marathon, since it just did what we wanted it to do. I mean, it supported easily scaling up and down. It supported random port allocation, which is something very important for Akka clustering. I could elaborate on that further if you want. And it was very easy to get started with. Deployments were basically just curl command with a JSON structure. So something that I really wanted was for the system to be flexible, so that we could easily change things if we wanted to. Being a small startup means that at each point, different decisions could be made which conflict with decisions that were previously made. So it's really important to be able to react to the conditions that were pressing us. It needed to be extensible because we actually started with 4 or 5 microservices, and at the end ended up using 6, and a 7th one was in works. It needed to be open. There weren't many people in the startup, so everyone needed to be on the same page. Everyone needed to have access to the logs, to the metrics, and it needed to be automated since we didn't really have the stuff to operate all that. So we decided to go with AWS, since this is the thing that I had most experience with. HA proxy for TCP proxying, really helpful, along with Marathon and Mezzos. Didn't really have any problems with it. We started with the V1 registry, but it wasn't very stable and the performance was horrendous because the performance tests that we were running could have started up to 20 nodes, for example, simultaneously, all of them trying to fetch the images. It was very painful. It died probably 3 times during a performance test initiation. Luckily, the V2 registry came out and we were very happy with its performance. So a performance test could have been staged in about 2 minutes. And I'm talking about 20 nodes with different container images, which are started from scratch. Every time we were bringing up new instances and dismantling them after the test. We decided to use Go as the continuous delivery software, since it really supports the notion of build pipelines, unlike Jenkins, which is kind of an abomination every time I look at it. The whole pipeline was automated with Docker, so I actually had to destroy the whole setup and bring it up again. I don't really remember the why did I have to do that, but with Docker it was really easy and everything actually started working without me doing anything. We have decided to go with a custom centralized logging solution. Of course, you probably know what I'm going to say. Elk Stack, of course, it was really flexible, did very well under load because we were pushing, I think, about 60,000 messages per second during performance tests. For the graphing solution, we went with Graphite. Again, nothing groundbreaking. We were using Grafana for dashboard. We were again pushing tens of thousands of metrics per minute. The performance testing setup was really interesting since it consisted of probably 3 shell scripts, but it was really powerful. You could start an arbitrary number of instances of different types. They were all configurable during runtime. You could have started it against different revisions of the software and many more knobs. I mean, there were probably 20 options when starting the pipeline. Marathon. Well, Marathon did really well. They were actually developing their features along with our needs. So at a point we really needed the random port allocation, and Marathon officially released that functionality. So we were very happy with that. This is how the system looked like. So we were terminating our traffic here. We were TCP proxying to 2 Nginx instances, which were cross-passing the traffic to HA proxy, which was TCP load balancing the traffic to 3 Marathon servers, 3 master servers. We had a bunch of slaves that were also using the HA proxy. So the configuration was dynamically created by a script that was fetching the data from Marathon. And at the back end, we had, again, HA proxy doing TCP load balancing to a cluster of Cloud instances and a cluster of Neo4j instances, since we were using 2 different databases. And the end result was that we had a really fast feedback cycle. I mean, from commit to deployment, everything was completely automated, and it took about 15 minutes to pass the cycle, even though we were testing and everything was containerized and we were pushing at least 6 images to the registry. The deployment was really, really flexible, since we could treat our infrastructure as something really generic. So I actually wrote the Ansible code to provision the Mesos and Zookeeper environment in about a day. And I haven't touched Mesos, Ansible before that. We could have scaled up and down at will, both at the instance level, obviously, and at Marathon's level. And the system was relatively easy to operate and debug, considering that it's a distributed system, since we had a lot of logging and stats collection. We had very elaborate dashboards, and we were showing a lot of metrics. So nothing's perfect, of course. So I would have changed secret storage if I could, because exposing secrets by env variables is not very secure, as you might imagine. Unfortunately, there isn't an easy solution for this. So I guess you can't really deploy this setup if you have high security requirements. And security updates, they weren't a problem for the JDK base image or one of the other interim images, but it was a bit of a problem for the Ubuntu base image, since we didn't really know when did security changes occur. So this is something to think on. And questions, I would like to make this more interactive, since I can't really share all the information. I don't remember the whole workflow. So hit me up. Yeah.
So why the random ports? Why is that important in Akka?
Yeah, well, if you have multiple services running on one host and one of them gets terminated, then another service might be, another container might be allocated at the same host with the same port, since at the beginning the allocation was performed in serial. And since we were using Akka remoting in order to tie the different clusters of the different services, the new container was automatically kicked out of the cluster, since it said, well, I'm expecting a different actor system here, I can't allow that. And it basically made the cluster dismantle itself. They're very strict in regarding to that. So.
Why did you use Nginx and HA proxy?
Because we were doing some fancy stuff, rewriting requests and stuff like that. Not that it can be done with HA proxy, but then again, we did TCP proxying with HA proxy and not HTTP proxying. And we needed that because we were using that for Akka clustering as well. And Akka is really stringent about the type of data that it's receiving. Anything more?
do you measure the demand or the load on the system? What kind of sensor do you use
Well,
in your system?
We are using Grafana dashboards for that, and we're monitoring that manually. But if we had the need, we would have created a script of sorts that would have been able to track that. Well, if someone is interested in making something like this work with Akka, you should know that you really need to have a seed node. And for that, we cheated a bit by using Zookeeper, so that each of the new actor instances was registering itself into Zookeeper, and all of the followers were checking Zookeeper for seed nodes. So that's the way we made them work, because Akka clustering by design is incompatible with such a setup.
There was another question over here. Hold on. Do the mic thing.
If I think I saw the architecture correct, and there was just one HA proxy in front of the the storage.
No, there are actually two.
Okay.
There is a lot of lines here, so it's not really readable, but everything was redundant, really.
Okay.
We were using custom attributes in order to facilitate, for example, cross-availability zone redundancy.
Any other questions there?
For kind of a similar project, we started with graphite and then went with Grafana because the images are, well, they were more helpful for the client. And you went the other way. And you almost said, you know, glad you moved from graphite to, from Grafana to graphite.
No, we actually used graphite's underlying storage, and it was also useful for metric discovery, since we had, I don't know, probably around 100 metrics per host, different metrics. And Grafana wasn't really useful when trying to determine what to graph. And as it comes to the front end, well, Grafana is indispensable, and graphite again is looking very ugly.
But for different metrics on the same calls, or different calls, different metrics?
Well, we had system level metrics were collected by collectd. They were pushed straight to graphite. We had application level metrics, which were pushed to statsd, and again, of course, ended up at the graphite backend. And we were using Grafana for in order to show the graphs. But graphite was really the storage for the metrics. And we didn't really have any problems with the Whisper storage engine. And we have been aware that we could use, for example, Cassandra as a metric backend, but we would have done this only if the need had a reason.
Any other questions? Nope. Well, thank you, Ivan.
Thanks.
Well done.